Hello, folks. My name is DC Rockwell, and this is your co-host, Elio Greco. Welcome to Code and Chaos, a pseudo-random conversation that starts with tech and ends an hour later. Tonight, our conversation begins with hiring. We wanted to have a conversation about what's it like to get hired right now? What's it like to hire other people? Elio, what do you know about hiring, and why is this on your mind lately?
Well, I have been for the last several years taking part in some industry collaboratives, and also doing some outreach and some advisory work with Department of Ed under the CTE banner and schools as well. And actually, not just CTE, but we won't talk about that one. That was a waste of a day. So yeah, about 8 schools, and yeah, it's been several years worth of looking at what does it take? What do we need in tech? And what do you need if you want to get into tech? I've mentored a lot of younger people getting in, and actually several of them have done quite well and are now moving up in their careers. So it's part of the reason I got into doing Code Day and all that is like I love working with really talented, awesome people. And I could be selfish and just take jobs that allow me to work on cool little teams and hoard all the awesomeness to myself. When I'm like, or I could, spend some time and try to share what I know and make some more smart people. And then in like 5, 10, 20 years, there'll be a ton of smart people that are awesome that I get to work with. So that's the route I went.
So it's kind of like how some people have kids so they can work the farm later on in life. Is that how it goes?
Yeah. I'll do a shout out to Curtis from Amazon about a decade ago, but not the farm, the salt mines. We'd always come back from coffee. He's like, back to the salt mines.
Well, I've had a lot of experience with looking for a job this summer. I was unemployed for a while because of COVID, and I was interviewing at a lot of different places, not doing such a great job at some of them. At some of them I was. So the thing I noticed right off the bat, the big difference between the ones I was doing well at and the ones I wasn't doing well at was the format of the interview. So let's talk a little bit about those formats. There's different approaches companies use for interviewing people. And one of the unfortunate ones that are very popular these days are, it's widely known as the whiteboard interview process. And essentially how it works is they'll bring you in and they'll start asking you questions, and there'll be a whiteboard, and they'll have you illustrate your thought process or maybe write out some pseudo code on the whiteboard or model out a system on that whiteboard without access to your normal tools. Yeah. I've heard a lot of split opinions on this approach. There are some folks who believe that this is an unfortunate necessity of there being so many people who want to get these jobs and not very many of those candidates that are able to talk the talk, speak the speak, and demonstrate certain kinds of skills that they're going to need to have on hand whenever they want. So in other words, they need to find people who all have the same vocabulary, the same lexicon, know the same sort of things, so that way we can put them in a room and they all have something to contribute. Whereas other folks, other companies, they seem to favor a more either free form or a different kind of an approach where folks are allowed to express themselves individually and show their individual strengths or their individual weaknesses. And then from there, we look at that candidate and see, well, do we have a position where somebody like them would thrive, where they would be able to contribute a lot, or maybe they only have a few things that they need to learn, and we can offer that kind of training within the first 90 days, which, anybody's going to be ramping up in the first 90 days anyway. So why not just slip in a little bit of training there and take somebody who's almost exactly what we want and give them just that little bit of extra information that they need in order to be exactly what we want. What's your experience so far with the former of these, the whiteboard interviews?
Well, when I got the job at Amazon, and when I went out to Seattle, I did the traditional whiteboard interview with, it's not just one, it's a whole bunch of different people for a good portion of a day. And you just do one and another and another. I think there were 5 or 6 people, and then there's a break for lunch, and you go out with the team, and then you do some more whiteboard interviews. I'm not a big fan. It's really unnatural. I think it gives you a really poor, it just doesn't tell you what this person is capable of. It's like getting a fine chef, someone with like Italian or French training, and you want to, you're thinking of hiring them, and you want to see what they got, and you're like, all right, so we're not going to do this in a kitchen. We're going to do this on a campfire, and you get like one pan, and you get some crap knives, and like, show me what you got. And here's like 3 ingredients. You're not going to get a good indication of what this person's capable of. You've completely taken them out of their element. Code is not written on a whiteboard. Code is written on a computer. So it's just everything about it is like the most artificial, the most like. And the other thing that just really blows my mind is, and this happened during my interview too, is a lot of the questions are these like computer science questions. Like, how do you balance like a red-black tree or a binary tree or any number of data structure and algorithm questions, which are cool and fun and good to know if you're designing low-level system stuff. But the time I've actually used those on most tech projects, it almost never happens. Like, unless you're building a database for some core piece of software, that's not what you're doing day to day. You're just maintaining stuff and just digging through and reading code and trying to debug. And so it's I don't know. To me, it feels like the worst possible way to find someone.
That's been my experience. Most of the time when I'm brought in and I see a whiteboard in the room and I find out that they're expecting me to get onto it, they're going to throw data structure or algorithm questions my way. And I've been taught by some experienced engineers that I've had these kinds of conversations with that this is the moment when you ask them when you are going to be doing this in your normal day-to-day activities. And based on their answer to that, it tells you whether or not there's a red flag going on already right away. Because if they're asking you to be an algorithm expert and the day-to-day does not actually involve algorithms day-to-day, means that there's some sort of disconnect in the process where they're trying to find the right candidate, and maybe they don't know what kind of work that they do very well. Maybe it's not very well structured, and maybe they have some other things going on in the company where they need to reach a certain level of maturity before they're going to be ready to hire these kinds of folks. Or it also could just mean that they have a bad hiring process. But in the end, if you have a bad hiring process, which is just so important for talent acquisition, it also probably means that they have some issues with certain personnel, maybe not being the right people for those roles. Anyway, it's just one of those things where I used to stress about it a lot, and I used to just study data structures and algorithms as much as I possibly could, even though they just don't play a large role in the kind of work that I do, where, the kind of work I do is business logic at scale. We have to make sure things go very fast, but for the most part, you don't even want to be inventing the low-level code that you're going to be using for doing these things at scale. You're going to want to use something that is an industry standard, a library that's out there, that's highly supported by a larger community, where they're going to be adding performance optimizations on a daily basis, as opposed to you who may implement something like that and then never look at it again for the next 6 years. So my experience with whiteboards has been that they are almost always an immediate red flag, with the exception of architectural interviews in which they're asking you to maybe draw a class diagram or a sequence diagram, where they're just trying to ask you something along the lines of, how would you handle authenticating requests to a RESTful service without hitting the database multiple times for every request. Then you can illustrate that up on a whiteboard a little faster than you can talk about it.
I think that's the key. Is the whiteboard is fine. We use that in programming to draw diagrams, to take concepts and discuss concepts. So if they're having you illustrate concepts, that's fine. That's great. That's perfect. If they are having you write source code on paper or whiteboard or anything like that, no, this is not how you do it. And the other thing that you mentioned earlier, which I think is worth, especially for the younger people getting into the industry, it's worth pointing out, is it really, when you're interviewing, there's actually a company locally called Axosoft, and they're the ones that did it was never a dress campaign, and they took the female bathroom sign and they redrew it so it was a cape instead of anyway, they've done some cool stuff. They had some neat things going on, and they did a whole campaign for a year or two a while back that was they gave out business resumes, and they're like, you are interviewing us. We want to make the case that you should come work for us. So interview us. And that's something that junior people just, they're just so happy they got the interview, and then they're all nervous. And I've turned down a whole bunch of jobs. We'll start talking like, all right, what's your stack? If if it's not published anywhere and I can't do the background research, it's like, what's your stack? What are you using for version control? Like, what are your processes? Just all kinds of stuff. Like, basically the stuff I'm actually going to be spending my time on day to day. Tell me how I will actually be spending day to day time, like 90% of my time. And if the answers are awful, if it's like, oh, we use .NET and we use like Subversion, and it's like, sorry, no. I'm not walking into that, willingly. Like, I want somewhere that at least is using something like Git, at least a modern version control system, is hopefully using a stack that's a little nicer. We'll come back to software stacks too. But yeah, I'm not a fan. I hear .NET is decent. I don't do Microsoft stuff. It's served me well my whole career. I stand by it personally. And I'd recommend other people try to do more open source stuff. But, I know people who got stuck with Windows, and they tough it out. Man, they have patience of saints.
I think there's plenty of folks that I met that prefer .NET. I mean, all of these languages, for the most part, they're all getting done the same sort of things in different ways. And some people, anyway, the point is that preference does play a role in the kinds of tech that we're going to use. Yeah. But that said, you emphasized mostly interviewing them on their tech. And I found that this is actually a minimal part of my interview with the companies these days. Now, and the reason why is because I kind of have some experience to know the kinds of questions to ask right away. Like, for example, just starting off with, what's the most difficult part of the system for you to work with? When you ask them a question like that, they go, oh, well, that's a good question. Darn, I was hoping you wouldn't ask that question, right? And so then they start talking about the toughest parts of the system to actually work with. Then you ask them some questions generally up front about, what's the tech stack look like? What are you using for the database? What's your framework? How do you deploy this thing? Do you have any linting? Do you have it? Which linters are a way for you to check your code before it's checked in to see if there's any common errors in it or formatting issues. And that's usually a good sign that folks do want quality. And then what's your test coverage look like? What are you using to test with? Once I'm past those questions, which don't take very much time to answer, you get on to, well, what's the toughest part of it to work with? And once you're past that, I spend the rest of the whole interview asking about the other people. I ask them, who do you work with that's really fun? Who's really fun to work with here and why? And you start listening to how they speak about the other people in the company. This is the most important thing for me, because you can always deal with tech. I've found that even if I happen to come in and all the APIs are in SOAP, which is a very cumbersome to work with protocol for APIs, I can eventually get used to it. I can eventually be like, yeah, okay, whatever. I'll find some tools to automate some stuff, or I'll find some tools to make it easier to work with. I would prefer, if I have an option, between a company that's using JSON and a company that's using SOAP and a company that's, using some proprietary thing, I'll probably go with the company that uses JSON if that's the only major factor between them. But for the most part, I'm really wanting to know, is there a problem with the people? Do the people disagree with each other? Are there chain of command problems? Are there issues where there's a lot of infighting? Are there questions that I can ask to find out whether or not this company has a lot of political discourse or political arguments and political, plays for power, things like that? That's the stuff that you can't really fix. That, as an individual coming into a new company, it takes a lot of time of building up trust with people, getting into a position of authority, and coming up with a really sensitive long-term plan to be able to fix things like people problems. And you, as a person who's just coming into a company, you're not going to be empowered to make those kinds of changes. And even if you were empowered, you wouldn't have the clout with everybody that's needed in order to do it in a way that you're not going to maybe cause everybody to leave. So that's the most important thing to me, is finding people that I just had a great time talking to on the interview. People that I would want to invite on this show, people that I would want to hang out with and do a code day with. Things like that. That's what I'm looking for. And not just that, but also you listen to how they speak about the other people in the company. If they're speaking about them like where they're excited and they just can't wait for you to meet all the rest of the people. Oh my gosh. Oh man, you're going to have such a good time talking to Zach. You're going to have such a good time meeting John. You're going to have a good time, talking to all these different people. You are going to have your signs right there that even if the tech is a little bit challenging sometimes, you're going to enjoy the challenge because you're going to enjoy the people you talk to, and the people you talk to will be open-minded to your suggestions on how to improve that tech.
Yeah, I would say, so I would agree with a lot of that. Although, like I said, I always start, even though that's worth spending a lot of time on the culture, I always start with the tech, because there's some amazing...
Start with it, yeah.
Yeah, there's some amazing computer science. Life is too short to write bad code and deal with crappy languages. Like, there's just incredible stuff out there. My latest kick is concatenative programming. Very cool stuff, brand new. The underlying formulas, the underlying theories from like the early 2000s. So we're still making progress in major areas of computer science. It's a very young field, and it just makes me sad when I see all these companies that are just, and we had a lengthy conversation off air a few days ago about, why is Java and JavaScript and Python, these are all imperative procedural or imperative OO languages, and they just dominate the industry. And if you look at a lot of the other language science and language theoretic stuff, most of the really good stuff, like, these are old ideas that they seemed good. And from the ideas in small talk of message passing and all this, like they turned into something else. But we'll save the architectural stuff for another show. But the relevant thing here is, to me, I notice a direct correlation when you're talking about people. Like, ideally, I want to work with people that know things that I don't. I don't ever want to be the smartest guy in the room. I mean, if I'm teaching, fine. For a little bit, fine. But I would rather be picking up stuff from other people. And I crave those opportunities to work with people who know a lot more than me, especially, if they're specialists in some area. I've gotten to work on some stuff lately with a PhD cryptographer, and I know a little bit about cryptography. I try to know enough to be able to implement it competently, but just fascinating talking to someone who like has spent decades of their career getting deep into the nooks and crannies of cryptography. So that's, besides the culture, I like to find a team ideally that I can be on, that I'm going to learn a whole bunch of new stuff. And I mean, you can read about stuff, and there's a lot of resources now on the internet, but learning from people who've actually had to not just learn the theory, but apply this in practice is the best. Well, for me anyway, I think it's one of the best possible ways to learn. So that's something that I'll look for too.
I agree with you entirely. I outsource that effort. These days, I found that what do you call them? Recruiters. They are the ones that are really going to help me out with that up front. They will go and ask those questions for me and come back to me with those questions asynchronously. So I don't actually have to make that a big part of the interviews. And the way I've built up my interview, how do I put it? Resources is through LinkedIn, because you get all of these seemingly spammy messages from people on LinkedIn where are you looking for a new opportunity? And what I end up doing is replying to them and just politely explaining to them, hi, I'm not looking for a new opportunity. I'm happy where I'm at, but keep me in mind. Things change from year to year, and here's these are the kinds of tech opportunities that I'm interested in. And I send that back. And invariably I get people who just say, cool, no problem. I can get that kind of those kinds of jobs. Or if I ever see something like that, I'll let you know. And then they just keep me in the loop and they just talk to me over the years. And then this summer, when I was really looking for this position, I just used every resource I could to get my resume out to recruiters, not directly to the companies. And I ended up with about 40 different recruiters, all individually submitting me to multiple companies each. And that got my reach out there. Unfortunately, some of them had double submitted me. One submitted me to the same company and the other submitted to the same company. And I had to go with a first come, first serve sort of deal where in my current position, 2 different recruiters submitted me to them and I had to let down the second one. And they missed out by like that much, like an hour. Felt a little bad about it, but that really works out well. I'm not sure how well you're going to be able to get recruiters to do the legwork for you if you're new in the industry. So maybe there's a challenge there, an additional challenge if you're new. But if you've been working in the industry for about 4 years, or something like that, you have a little bit of you have some experience to show on paper, especially from the last 4 years. Then recruiters are very interested in getting you out there because they get a small commission for having found you.
Yeah, I find the recruiting stuff to be a little bit hit or miss. There are definitely a few that are excellent, but there's also a lot that are just, I don't know. There's a great website. Especially in cybersecurity and to a slightly lesser extent in programming, you get stuff like some of the job requests are just absurd. And there's this awesome website that's open source this guy made called howoldisit.glitch.me. And it is a listing, an interactive listing of every not every, but a lot of technologies, popular and some less popular ones. And you can search, you can order by the tech, you can order by the age. And so like .NET Core has been out for 4 years. .NET Framework is 18. Ada has been out for 41 years. Agda has been out for 22, etc. Because you'll see these job requests that are asking for 12 years. And you go and you're like, wait, that's like a 6-year-old technology. How no one has 12 years. There's actually a Twitter post recently. This guy, they were asking for 6 years. And he's like, well, I guess I can't apply. I guess I don't qualify. I mean, I did create the technology 3 years ago, but I guess I'm not qualified, to take this job, even though this is my creation. So, it's a little, and I will say that's, I guess, a little more on HR than on the recruiters. But yeah, I would be careful. I find it maybe a little leftover trauma from recruiters and what that means in the military, because all smiles, but man, watch yourself and get it in writing if it's a military recruiter. They're on a mission and the mission's not you.
This is true, but I think that this is also, it leads to a good point, which is you're interviewing the recruiters first. And you are going to be talking to them. And I talked to way more recruiters than I ended up working with. Many of them did not really know what it was that they were talking about, and I just basically had to tell them, hey, actually, Java is a different language than JavaScript, and I'm not looking for Java opportunities. And a couple of them, I had to explain to them, the difference between certain technologies and why it was that I wasn't going to go with it. But I used it as an opportunity to just sort of, to talk to other tech professionals that may not know as much as what I know about that particular subject. And I try to help them out, actually. I try to just be of service to them and just say, hey, I think what you're really looking for is actually this, So like, for example, somebody was looking for an encryption expert, and they weren't really actually looking for an encryption expert. They were just looking for somebody that knew how that programmed with who was a security-minded programmer, and after talking to them, talking to them long enough, I finally could see what it was that they were really looking for. And I just suggested that maybe it's not worded quite as well as they thought it was. But mostly the first step is going to be to put together your resume. When you get your resume together, ideally what you want a recruiter that's going to review your resume and then give you tips on how to make it even better. And some of those tips I found were self-serving. They wanted me to change it so this way it looked better to a particular client. And with one recruiter in particular, they kept requesting a new change for every single one of the clients that they were submitting me to.
Wow.
And I ended up having to tell them, well, I think it's just good enough. If I don't get the job with this particular resume, then I don't think it's the right position for me. I don't think we have to tweak it quite that much. And they're like, well, if you tweak it a little bit more, I bet I can get you $10,000 more. And I was like, let's see if we can get it with this. And if they want more information, then I'll draft up something and I'll send it back over if it's still interesting. But the point is you want to interview the recruiter. You want to make sure that this recruiter, understands well enough what it is that you do and what it is that they're looking for, because a lot of them are winging it. A lot of them really do not understand what these things are that they're looking for. They're given a job description document, or it's basically a job description document, and this job description will have certain kind of keywords on there. And if you are a good recruiter, if you don't know what a keyword is, you're going to hit up YouTube and you're going to start watching videos on it, and you're going to try to gain a working understanding of what is this thing good for, who's using it, things like that. If you're not a great recruiter and you really just don't care, then you're just going to repeat that term to another person without even understanding what it is. And some of the classic cases, like I already said, were folks who don't know the difference between Java and JavaScript. It's very, very common. Folks who do not know, they'll ask you, okay, do you know Node.js? And you go, yes, I do. And they go, okay, do you know JavaScript? And you're like, And you're like, well, Node.js, it is it is JavaScript, actually, and you have to explain to them, sometimes I had a particular conversation with one recruiter where I explained to them the difference between JavaScript in a browser and JavaScript on Node, which is really just these core modules that it has access to. And, that helped them out. It helped them out, and I think that on the next person that they were going to try and recruit, that they were going to, do a little bit better for themselves and the other folks. You find the right recruiter, and then the right recruiter really does help you out, and they really do help you get all the way over that finish line.
Yeah. Now, the alternative is you bypass HR and recruiters to the extent possible. And one of my favorite things, before COVID and hopefully after, will get back to doing meetups. And I, both looking for work and also looking for talent, I find meetups are the best place to go. because meetups are where there's people that just clock in and they want their money and then they clock out. And that's it. And that is a problem. You shouldn't be spending 120-hour weeks. Like there's some people that just kill themselves to like get in early and stay super late. That's not healthy. So I'm not advocating an insane work schedule where you're just working yourself to death in some cases, literally. But what I am saying is there's some people that are just there for the paycheck, and there are some people that are really interested in the computer science and, you know, pushing the art forward. And those people tend to go to meetups. So in going back to that culture, I want to work with people that are really interested in what they're doing and are passionate about what they're doing. And I hear this again and again from a lot of the C-suite people on some of these collaboratives. And it's interesting because they're starting to de-emphasize certificates in school. And there's such a huge industry there that, you know, everyone is still really into certificates in school. And, you know, if you have an opportunity, it's not a bad idea to get certain certs, and it's not a bad idea to have a degree. Although I say if you're going the college route, I say differentiate yourself. If you're going to spend the time to get a degree, don't waste your time getting a computer science degree. Get something interesting. Get a degree in something in the humanities, psychology, sociology, history, anything that's interesting to you. And actually, there was a woman on LinkedIn, I forget her name right now, but she had this cool little 5-minute video of how did she get into cybersecurity. And she was an English major with like a minor in sociology or some such. And she found her way into cybersecurity, and she's now well respected doing awesome stuff. And I'm like, I'll bet you that English and sociology degree comes in real handy dealing with some of the people you have to deal with in your role. And she's like, oh yeah. Oh yeah.
Mathematics as well. That's a huge boon to a programming career, I believe.
Yeah. So I would say, if you're going to get the degree, get an interesting degree. Right now, a lot of the classes, I mean, there are really, like, don't get me wrong. You go to Stanford, you can take classes on concatenative programming and all kinds of crazy, insane stuff. MIT, Carnegie Mellon, you know, there are some universities, Berkeley, how could I forget? Berkeley Standard Distribution is one of my favorite OSs. So there are places you can go that are, you know, cutting edge. But if you're talking just a state school or one of these that's not on the ultimate cutting edge of technology, get something interesting. Take a data structures and algorithms class. I will say, being self-taught, that is my one, like, oh man, if I could go back and do it again, I would definitely have taken a data structures and algorithms class before I had moved on to some other stuff, because it was not fun hearing other people on the team. They're like, oh yeah, you just use red black tree. And I'm like, what now? And I would have to like rush and go look it up, be like, what the hell is a red black tree? And teach myself what that data structure was. So now I have a half decent understanding of different data structures and algorithms. So that's useful. There are definitely some classes. I would recommend that. I'm trying to think, are there any other classes you would say are kind of must-have classes? Not obviously mathematics you mentioned. I will say that some of the math they teach is not well aligned until you get way into college. Like the stuff programmers, our bread and butter is Boolean stuff and logic, ring theory, set theory, graph theory, all this really fun stuff you never see till way into college. And it's simple enough, like the gist of it can be taught to young children, like as young as 5 or 6 in some cases. If you've ever played the game Sprouts while waiting for food to come out, where they have, you know, placemats you can draw on, that's a great application of graph theory that's actually not computable by computers. It's just too many different options. But that's the kind of stuff. So I don't know. I mean, standard math, like the standard math curriculum up through like college level, like standard college level without going into a math degree, I find is not bad to have. It's helpful. But the number of times I was like programming in a ton of, you know, straight up mathematical, like calculus equations, like there are some things like game engine design and simulator design and all this that, yeah, you're going to be doing that all the time. But your day-to-day CRUD applications working at something like Amazon, Facebook, Google, maybe Facebook, you're going to be doing a little more systems design, but you're not actually going to hit that stuff day to day for the most part.
No, I agree with you. You're not going to be using it day to day, but the folks that I've worked with who are programmers, they also have an advanced math degree of some sort, or at least they're very talented at mathematics. They they find the right moment to apply them. We'll have a problem that is very difficult to quantify, and they'll be able to write up a formula real quick. And they'll, or for example, somebody was, we were going through some agile management training one day, and the person that was training us said that if one team were to scale the same work on a scale of the Fibonacci scale versus a 1, 2, 3, 4, 5 scale, that it basically all in the end all averages itself out once you integrate these numbers up into the higher level epics, which sounds like Greek if you don't know anything about Agile, but essentially what it means is that you have a bunch of different tasks in your work, and generally you're going to assign point values based on how much effort there is to do in each one of those tasks. And in some teams, they'll use a 1, 2, 3, 5, 7 scale. And in other teams, they'll use a 1, 2, 3, 4, 5 scale. And they keep going up from there. And this guy that I worked with, Brent, if you're listening out there, this is your story. He was able to quantify by coming up with a small little formula. He was able to quantify the actual difference between these two estimation methods, and he was able to show how if one team were to say, and actually I got the premise of this a little bit wrong, but basically the idea was if one team consistently calls a certain amount of work ones, and the other team consistently calls that same amount of work twos, he showed how at the smaller point differences from a 1 to a 2, you are doubling the amount of overall points in a project, actually. And the difference becomes smaller when you go from, say, a 3 to a 5. There's actually only 2 points of a difference. It's not doubling it anymore. And so you need to be more accurate at the smaller units of 1 to 2, because if the same team says, hey, you know what, these are all 2s, and that other team says they're all 1s, one team is estimating twice as much work as the other team for the same amount of actual effort. And this ends up over the course of many, like hundreds of tasks, this ends up being a difference in your epics, which is a roll up of many tasks into a large epic amount of epic project is basically what it is. An epic project is just a large project. Then you have the same projects, the same 2 projects estimated by one team as taking 6 weeks, and the other one, it's taking 12 weeks. And he goes, that's a huge difference. And just right there on the spot, was able to use a very small amount of basic algebra, but the way he thought about the problem was in terms of a mathematical formula, was able to write it out real quick and show to our class that actually, no, we can't just, it doesn't just average itself out. In fact, it's very important to have your estimation process accurate, especially on the smaller stories or tasks, which, if you're doing it right, most of them are going to be small. So anyway, he also ended up applying that. He applied his mathematics background to showing how a lot of our stuff could be predicted with standard deviations, and he could come up with models that would show us where we needed to put in certain kinds of alerts in our system in order to know if a problem was going to happen, say, the next day. And he was just able to apply it at these very specific points because the way he thought was in terms of, I'm going to mathematically model this out. I'm going to figure this out with some rigor. And for the rest of us, it would have taken us a lot longer of trial and error and doing things in order before we would actually get to that point of thinking to think of it in terms of a mathematical model. Because I'm just a programmer. I'm a logic thinker, not necessarily a numbers and algorithms and formula thinker. I don't necessarily break things down as mathematical models habitually. I break them down into logic branches, and I think of things in terms of loops and memory allocation and stuff like that, and it's just a different way of thinking.
Yeah. I wish the curriculum that they were teaching in schools was better aligned to the needs of computer science, because there's this huge push for STEM and STEAM education, and just the math they teach, again, some of it's useful, but there's other stuff we could be teaching a lot sooner that's extremely useful. That stuff you kind of have to be self-taught. And like you said, unless you got a math major or math PhD, you're going to have to teach that to yourself, because it's just not covered until way into college. So, the logical thinking. And again, we talk about stuff like lambda calculus as underlying certain languages like Lisp and Haskell, which, people hear calculus, but very, very, very different from the kind of calculus you're taught in high school and college. Totally different thing. So we're talking about function, composition applications, et cetera. We're not talking about doing derivatives and integrals and all that. So I would say the other thing that we talked a little bit about, you want people to have passion. The other thing that is not really covered a lot from the looking for talent side is they need to be able to communicate, and they need to be able to work together. And in school, you're taught to sit down, be quiet, and do your own work, which is unfortunately exactly the opposite of what we need in programming. You're going to be on a team. Anything you're going to build that's more than some little trivial thing. I mean, it's honestly hard to think of really big, interesting projects. There's a handful of pieces of software that one person built them. Most software that's really interesting and widely used is a team of people, at least 2 or 3, sometimes a whole lot more than that. And so working on a team and being able to convey your ideas and communicate and make sure everyone understands, and then documenting it, because even if you are the only person working on a piece of software, unless it becomes your life's work, you're probably going to move on to another project. And so getting that documented and written down in a way where other people, or just you 6 months later, can read it again and be like, oh, that's why I did it that way. I remember now. That's critically important, and I feel like it's overlooked a lot.
I agree. I had an opportunity to take some electives for a conference, and one of them was on technical writing, and I jumped at it because I know the importance of technical writing, and I wanted to know, were there any cool tricks that I don't know? At that time, I'd already been technical writing for over 10 years, but I learned some great tricks from that class, and I think it should be mandatory, training for just about anybody who's going to be a programmer. You're going to end up at some point in your career needing to document something that you did, or explain, perhaps it's a post-mortem on something that went wrong. Sometimes it is a technical proposal for something that you'd like to see improved. These are all places where being able to organize your ideas in such a way that 2 different audiences, a non-technical and a technical audience, can both read the same document and get as much out of it as they need to make an educated decision on what it is that's in it, is invaluable for business. It's invaluable for just teamwork, because otherwise what you have is a bunch of people having conversations, and only the people who were present at those conversations and who have real great memories can remember all the details of that conversation. And then you usually have either just a semi-random vote, or you have somebody who's playing dictator, who's just, the person who makes all the decisions. And it doesn't work as well for teams. Especially, it doesn't scale well once you have larger teams and larger companies where you have a lot of competing ideas. Most of the time, you do have to propose an idea in a technical way that allows the non-technical people to also have input into it, to look at it and read it and digest it for maybe a week or 2 weeks before anybody has the information they need in order to make a decision on whether or not to adopt it. So very much a proponent of technical writing skills and developing them continuously over your whole career.
And another interesting place that crops up, I have a friend of mine who does security. He was head of incident response at a major global corporation. And so he's in court almost every week as an expert witness. And he has to do the same thing where he has to write. It's really hard because he has to write it up so that it can be presented in court so that it's completely true and there's nothing even misleading or vague, but simple enough where the jury can understand it, because you don't know, the jury could be anyone. They could have any background, but it's got to be fact-filled and detail-filled enough where an expert can look at it and say, okay, yes, this guy knows what he's doing. He hasn't missed anything. But like I said, also simple enough where just an average, you have no idea who the jurors are going to be, juror could look at it and say, oh, okay, well, that does make sense. Like, yeah, no, it sounds like, and that's really hard to do, to make something detailed and comprehensible all at the same time.
Arguably, every company does have its own board of jurors.
Yeah.
They're called the executive team. And these folks, they're very good at what they do. But few of them actually have the deep technical knowledge into the engineering departments and what we're doing in there and their implications on the business and the business model, maybe, and also on finances and things like that. And so you don't want to do the job of your CFO. Believe me, this is a very complicated, very technical job in its own right, and they don't want to do your engineering work. So you have to find a way to bridge the communication between these two worlds. And it's certainly, I would say, more efficient and certainly more, how do I put it? It's just, everything goes a lot smoother if you do have an executive that is highly technical who can sort of help take what it is that you've written or you've proposed and then translate it a little bit more into executive speak, if you will. But, a lot of companies don't have that luxury. And so you have to get the communication done somehow. And it's just better off for everybody if you know how to do it yourself.
Yeah. And so right along with that, the other thing, I think some of the most important aspects are problem solving and systems thinking. And this is something that I feel like is in very short supply in the world right now. Everyone's thinking about their little piece and what it means to them individually. And we have a lot of stuff right now, from COVID to global warming to ocean acidification. Oh, there's a ton of stuff going on. Government, like all of these things, none of them exist in isolation. They're all part of larger systems. They all interact. All of those things interact with each other at the same time. And that's exactly what you're doing in, especially it's something like Amazon. You have a massive global service-oriented architecture, SOA. You have all kinds of computers, literally hundreds of thousands of computers at a minimum from all over the world, all talking to each other and sending messages and figuring out what's going on and what's working and what's not working and why it's taking more time than it should and all that. Like, you've got to be able to see it as an entire system. And then the other term, self-starter, I guess, but really just, motivation and problem solving is a critical thing. Like this, when you get hired, a lot of the stuff you get, whether it's a startup, whether it's a big tech company like Amazon, Google, you're not going to get a little piece of paper, like a syllabus like you get in school of here's all the things we want you to do and here's how we want you to do them and exactly when we want you to do them. And, you're going to get a sentence. You're going to get, hey, we need to launch in, South America, in this country. So make it happen, figure it out. You get one or two sentences. And then the first thing you're going to have to do is like, okay, what does that mean? So where do we put the servers? Do we have to put the servers in country for regulatory stuff? What are the regulations? Are there latency issues where they have to be in country? Can we use a neighboring country? So do we need to stand up a new data center? What are the time zone issues? I'm not going to regale that, but there was a major time zone issue. It took us 9 engineer days to track down that was preventing us from launching one time. And it was really just bizarre set of circumstances. And we finally found it. And we're like, that was it, huh? Just whoops. Someone could have randomly picked any other hour and everything would have been fine. And we just spent 9 engineer days, 3 of us for 3 days, tracking down that it was a time zone issue. So all kinds of little stuff like that. And that's the thing, is like you are literally being hired to kind of be on autopilot. So when the execs say, we want to do this, make it happen, as a programmer, you're the one who needs to figure out what that looks like and how it's going to happen. Or if it just can't, every once in a while you'll hit something, you'll have to come back and say, we can't do that to spec. Here's the issue. It's going to take longer. It's going to take more money. We don't have the proper technology. We're going to have to either build or source a new technology to make that happen. Like, we can't do analytics. We're pulling 10 terabytes a day and we cannot run real-time analytics with this data store. We're going to have to find something different. So
yeah, I mostly agree with that. If you're in a smaller startup, you're probably going to be directly interacting with maybe an owner or an executive. Yeah. You may be directly interacting with them, and that is definitely what's going to happen. They're going to say, here's the problem, I want you to fix it. And then you have to figure out how to do that. This is why I think for many newer programmers, it's better to try and get a job at a larger corporation first, just because then you do have these tiers of management where the executives talk to a director and they say, hey, I need to launch in South America by this particular date. The engineer then talks that the director of engineering would then talk to the director of product, who would talk to the director of marketing, who would talk to the director of all these things. And they would then get onto a conference call and they would figure out, what is that list of those things that we need to do? And they would figure out who do I need to delegate a lot of these decisions or a lot of this discovery to? Then once they have that good idea of what it is that they need, then they can send that down to upper management. And upper management is going to then take this list of things, these requirements or these goals that we need to get done, and they're going to know how to delegate that out to a bunch of team leads and break apart that large task into smaller tasks. So the director of engineering would give their goals, their engineering goals, to these team leads, and these team leads are then going to break up their workload as well into smaller user stories. And generally, what you this is in a I got ahead of myself just because I didn't want to confuse everybody with the idea of product. But normally, what happens is actually product breaks this up into user stories, and then these user stories are then handed over to engineering. Engineering then delegates out these blocks of user stories to different teams, and then the different teams estimate them and ask the questions that they need in order to know the specifics of how do we get these things done. Product and engineering works together in order to figure those things out. And at the end of the day, what you have as an individual contributor in one of these larger companies is just a backlog of tickets that all have acceptance criteria in them, which are essentially the things you have to do in order for this story to be accepted as finished. And you are allowed to just grab from the stack and start working. And you do have very clear goals and clear instructions on what it is that you have to do that day or for the next couple of days. And you have a team that has a stand-up meeting every morning. And this stand-up, meeting basically allows everybody to talk about, where they might need some help, or I might be blocked on this thing. I don't know how to do this thing, or I need somebody who's an expert in this particular part of the system who can pair with me. And you get a lot of support, and you get a lot of the planning work that's involved done for you up front. And this is why it's so easy for us to, for somebody who's new to programming to just jump right in and get stuff done within the first couple of months, because they're not expected to translate what the business wants. They're expected to take place in some, they don't even lead the rituals. They just attend some rituals. They're given some guidance as to what to do during those rituals, which is like grooming stories, pointing those stories or estimating them. And then they're told which ones of these stories they need to pull during the week. And then they just work them. And then as they learn more about that, they can move themselves up to an actual like middle management or like a team lead sort of deal. And they can start leading their own team where they're given a stack of stories and then they have to run the rituals. And then from there, they can move up again and eventually find themselves as maybe a principal engineer who's working across multiple teams to help out multiple teams. And then from there, they can eventually find themselves becoming the director, maybe. And then they are talking to the executives, but they're also generally not doing their own code at that point either. But you can also just learn how to be an individual contributor and how to be a team lead and speak to those other positions above you, and then go and work for another startup and, for the most part, just emulate what it is that you were seeing there. So that's why I suggest, that newer programmers may want to consider actually working for a larger corporation, because they really do give you some training wheels. So this way you can come in, you can start immediately building confidence by delivering value, and also have exposure to all of the people who know all the things that you're going to need for the rest of your career. And most companies will give you time to do that kind of cross training with them.
I'll push back a little bit on that and say there is a trade-off, whether we're talking programming or medicine. Anytime that you're going with, a small institution versus a huge institution, there's several things that come into play. You're right. In theory, you have access to a lot of resources. And in some cases, that's true. You get some really good people. If you're working at one of the FANG companies, Facebook, Apple, Amazon, Netflix, Google, et cetera, then yeah, you should be able to find some people. But I was actually really surprised. There were fewer people who were down to go do a startup. There were a handful, but most of them were like very senior management type people. And the people that I was mostly surrounded with on adjacent teams were not really thinking about doing startups. And so the thing you got to watch out for in a large corporation is, yes, everything is prepared for you. It feels very much like school. And so you're not pushed that much. You just kind of do what you are told to do. And you're not going to have as many types of problems. It's going to be pretty narrowly defined. And in the worst case, we actually had someone at the cyber warfare range that came in years and years ago that we're like, yeah, what do you want to do? And he's like, oh, I want to de-rack a server. Like, wait, you work in a data center. What do you mean you want to de-rack a server? He's like, oh, my team doesn't do that. And so there you get hyper specialization where you won't even do the entire job. You won't even be the guy who racks and de-racks and, plays the hardware. You'll be like the team that racks up the servers, or the team that de-racks the servers, or the team that maintains them when they're, just in the rack and operate. And then you'll hand off to another team to do a different function. So like a family friend who was going into nursing, she went ahead and she got this tiny little hospital. She went to this teeny tiny little hospital, and she had to do everything. And startups are like that, where, yeah, you're going to get a lot less guidance because you're going to have to do everything. And it's going to be really good training. And I recommend, do the startup at the beginning of your career when you can take a lot of risk, where if it all falls apart, because startups are notoriously difficult, you could just go couch surf and, don't try to wait till because then you're going to have kids potentially. And then you got to wait till they're out of college. And then, it's going to be the very end of your career when you have a lot less energy and you have a lot more responsibility. And that's when it's really hard to do a startup. And so I would say just go for it. Do the startup first. Take the risk. If you have that kind of tolerance for risk. The other thing is the people you're going to be working with, it's going to be a handful of people. And those people are going to tend to be really high performers. So you're going to learn a heck of a lot. They're all going to be in it 100% because there's no fat in a startup. You cannot have any inefficiency or the thing just fails. So you're going to have really, like I said, I loved working with startups, and I don't know, it was interesting. It wasn't terrible working at larger corporations. I missed working at startups though.
So let me clarify. I've never worked for a super large company like you have. I've never worked for an Amazon or Facebook or Google sized company. And that's not what I was actually suggesting. I was suggesting a just slightly more developed, a slightly more mature startup, which would be,
Gotcha.
Like the company I work for now has distinct product departments and engineering and sales and the executive team, and they're all separate departments all working together, as opposed to the kind of startup you and I, started out when we met each other, which was a guy's house that we worked out of, and he burnt steaks for us when we were wanting to get lunch. He was like, you keep working, I'm going to cook you a steak. And we're like, oh man, maybe we should just leave, but, anyway, the point is that I think that both of them are legitimate ways of entering the market. It's that if you prefer to have the instructions for what you're going to do this day clearly defined, and you want to also have access to some people that will teach you how to learn the skills of being a team lead while having the resources of actual teams to lead once you're ready. And also you want to be well shielded away from what the executives and the business are going to be, asking for, which is just point blank problems looking for answers. Then these smaller medium-sized startups are a great place to come in and be incubated to that point. If you are the type, frankly, like Elio and I, where we just wanted to jump in and be involved in everything right away and just get thrown into the deep end, where we had immediate exposure to every part of the company from day one, then very small startups are where you want to go. I would just warn you from our experience that the people who own these companies and the people who are running these companies are going to essentially dictate your lifestyle when you work for these folks. They are going to, for the most part, set the rules for when you're going to sleep. They're going to set the rules for when you're going to work. They're going to set the rules for when you're going to lunch. Things like that.
I mean, that said, so that was my experience with Amazon too. And that's one of the reasons I didn't stay very long, is when we did startup stuff, and I've done a number, you always you're kind of killing yourself for it because there's just so much to be done and there's so few people to go around. And if something goes wrong, there's like 3 or 4 of you. So if the server goes down, you get to wake up and figure it out and fix it. And it's you and maybe 1 or 2 people are up, because generally someone's doing business stuff, and then maybe you have 2 devs. So that's not fun. But at the same time, Amazon, I still had a pager. And I'm like, wait a minute, I own like 0.00001% of this company. I am not waking up at 3 a.m. to make sure Bezos gets richer. Screw that. I will wake up at 3 a.m. and stay up for 48 hours to make sure my portion of this little company is worth something. But I'm not doing that for someone else. Hire some more people. Like, this is ridiculous.
On the other hand, though, you were shielded from when Bezos had a bad day. And, we weren't. When the guy we were working for was having a bad day, we immediately got it, right?
Not everyone's that pathological, but yeah, you do have a better than average chance in startups.
And that was the point.
Interesting
That's
people.
Right. Agreed.
Good and bad ways.
But that is the main point, which is if you're working for a small company, just know that person is going to essentially, the person who's in charge is essentially going to be able to dictate how the culture of this very small company. And so pick your company I would say pick your company, maybe not more on, but just as equally on how much you trust that this leader is going to treat you well as giving you the opportunities you want.
I say that goes for any company. And I say at a smaller company, though, you have more ability because you're a larger portion of the company to influence the culture. Whereas the corporate culture at something like Amazon, I mean, yeah, you can have a team culture. That's going to be a little bit different. But overall, they have their leadership principles and you're kind of stuck within that. And either you love them and you get along with it, or you're like, I hate this, I'm out. So the thing that I like is also, like I said, life is too short to do crap technology. There's such cool computer science and so little of it's out there. And my favorite part of starting a new project on a smaller company, at a little tiny startup, is always like, hey, we got to build this thing. What are we going to use? And just going around and having everyone on the team. And we're like, oh, I think we should use Rails. And you're like, okay, that's not bad. And back in the day, it was like cutting edge stuff. And you're like, yeah, well, have you heard about this new thing called Elixir? That sounds perfect for what we're doing. And then, well, what about Pony? That has even better latency numbers than Elixir, and parts of it are formally verified. And you're like, oh, that's amazing. Let's use that. So you can really go around. And if you go with a larger company, Amazon is actually one of the few that a lot of like Google and some of these others, they have like the language, and they have a very rigid way of this is how you code. Google invented its own language. They invented Go basically to codify some of their practices and make their own perfect little language. That's exactly what Google needs. So, you know, if you have your own little company, and Amazon, each team gets to pick, which means you have dozens of languages. Like, well, we're using Java and we're using Perl, and these guys are using Lisp, and these guys are talking about Haskell. And that's kind of cool. But it's also like when you have to work with another team on a more involved project where you guys are actually having to like work on code together. I mean, it's kind of fun to have to like learn Haskell or learn Lisp or something in 2 weeks. Kind of. But I don't know. And I find it more fun in a startup atmosphere to try to scramble and do stuff like that versus like, oh, that team chose what now? Cool. I get to learn a new language. Plus I have everything else I need to do. This is going to be a week of very little sleep. So,
well, I don't want to start a fight, but my experience has been that when you're in a small startup and you're going, well, what about Elixir? What about Pony? And folks, and you end up building out this great application that works. Well, as your company starts to grow and you have a need for a lot more talent, then you end up having the executive come in and say, I'd like you to just rewrite this in Rails. Because we can't hire Pony people. We can't hire people who know Pony. And so you have the flexibility up until you have to scale out the hiring process. And then you end up understanding why a lot of these companies just use React, use Rails, use
Java, JavaScript, like Python, Go. And so Go is really interesting because Go, like I said, was designed explicitly for Google. One of the reasons I actually am not a fan of Go, it's not a terrible language. There's some interesting things about it that are kind of cool, actually. Like amazing cross compilation support, like blows everything else. Rust is pretty good, but Go is way better for cross compilation. But there's other stuff about it that you're like, that's a really bizarre. Why would you do that? Like, Go's not an old language. It's a new language. We know that generics are a good idea. We know that not having generics is going to make you write just a whole bunch of boilerplate code that you just shouldn't have to, that the language should handle. And if the more code you write, we know that there's a minimum level of errors that programmers, even the best programmers, you're talking somewhere. I'm going through studies for a current project we're on, but the number that I've seen that kind of keeps going up, and they're all over the place, but the kind of average is about really experienced programmers, about 7 external errors per KLOC. So for every 1,000 lines of code you write, as hard as you try, 7 errors are going to slip out to your customer, to the real world, and cause problems. And that's really experienced. If you have people that are tired and inexperienced, it's going to be way more than 7. So stuff like that, like Go, the reason it makes bizarre decisions that make you write just like a lot of extra code is because Go, they're just like, well, we just want, like you said, our priority at Google is we need tens to hundreds of thousands of programmers globally. And so we want programmers to be fungible. I want to not care if it's either of you, either of us sitting there. I don't care whose butt's in the seat. I'm going to make a language that just doesn't give you much to work with. It doesn't have very powerful tooling. It has a few key things we need. It's really good at concurrency. It's really good at network stuff. We build all that in, that's Go. But the language itself, the syntax and the tooling and all that, it's kind of okay. But it's intentionally like kneecapped so that you can never be too clever, so that any programmer can just be dropped in for any other programmer at any time. And if you rage quit because you had to carry the pager for an extra 2 weeks or something, cool. We'll just drop some other new hire in there, and close enough, they'll come up to speed real quick. They'll write a whole bunch of mediocre code. We have processes in place to kind of deal with mountains of mediocre code. And that's the priority, is hiring. And so I think Go is your logical conclusion when hireability, like I need lots of talent. That's, I'm not looking for the best. I just need lots of programmers quick. That's Go. You end up with Go.
Yeah, or JavaScript,
Well, yeah, I mean, JavaScript,
everyone and their dog knows JavaScript now,
Yeah. But that wasn't designed specifically for fungibility of programmers. It's an interesting language.
Yeah, I was actually surprised earlier when you were talking about object oriented that you didn't use our pseudo object oriented acronym there. But
yeah, there's for anyone, spell that out. Pseudo with a P, object-oriented programming, or the other cleaner one is object-oriented programming systems, or OOPS.
Yeah. So yeah, I think that really does sort of cover off on all the things that you need to consider when trying to get a job or you're trying to get hired. Is you want to be looking, just to recap some of the things we were saying, is, you want to initially do some sort of tech scouting on what kind of tech stack are they using, what frameworks are they using. When you're looking at a bunch of different companies and you're comparing them and you want to know which ones should I go with, you really need to know, is this company using a technology that I think is going to be interesting to me, one that I want to learn more about, one that I want to grow in. And if I do spend 2 to 4 years at this company doing this particular technology, and I want to find another job at the end of those 2 or 4 years, is my experience going to be relevant at that time? So you want to think about that. I mentioned that if you go the recruiter route, the recruiters can, for the most part, do this legwork for you, but then you have to interview your recruiter, and you have to make sure that your recruiter is going to understand what it is that you do and understand what these companies are looking for. And some of the recruiters know more about the tech than others, and so you're going to have to hire your recruiter in the same way that you're trying to get hired.
Yeah.
Once you get into that interview, you want to ask certain kinds of questions, because the interview process is your opportunity to interview the company. You are the one who has a lot of different options out there, a lot of different companies that you can choose from, at least choose from for the interview. And if you choose the wrong one, you're going to be locked in for a while with a company that you may not really want to work there for either the tech reasons or the people reasons. You might not like the people that you're working with. You might not like the tech you're working with. You might not, there might be just, you might not like the corporate structure you're working in, for example. And so those are the kinds of questions you want to ask during the interview. You want to start with some technical questions and just ask things like, what's the toughest part of this, of your tech to work with on a daily basis? Where do you have the most problems in the software? And then you want to ask tough process questions like, what's the most difficult part of working with the people at this company? And then you ask then questions about that get them to talk about the other people in the company. So you ask positive questions like who are some of the people that you work with here that you really enjoy working with, and why? And you listen to how they talk about the other people in the company. Sometimes they will be like, well, I like a couple of people here. For the most part, it's just a job. And you're like, red flag, right? But if somebody is saying, "Oh man, whenever I get to work with Brooke, I learn so much from Brooke. Brooke just teaches me all this stuff. Whenever I get to work with Autumn, she's so smart, and she just figures out all of these extra things, that I didn't think of, these questions that I didn't think of asking, and I learn how to become better at what I do." Those are the people. Those are the kinds of companies you're looking for, where people are excited to talk about the other people they work with. They're excited to talk about some of the tech that you're working with, that you would be working with. And for the most part, you're looking for people who are in the interview smiling. They don't look depressed. They don't look like they're just like, ugh, I'm having to do this thing, and I wish I could just get back to the crappy work that I want to do. And so that's the big thing, is you just really want to be interviewing them believe me, they're going to do, if they're doing their job, they're going to interview you too. But your job in there is to answer their questions honestly and to the best of your ability, but also to ask them the best questions you can to upfront determine whether or not this might be a mistake. Maybe you want to go to some other company.
Yeah, there's something I want to add to that. So one thing I was really impressed with, specifically with the team I was on at Amazon, which was Skaplat, is there was a ton of time. There's quite a bit of hiring. Amazon's always hiring. And so the amount of time, I can't speak to any other teams, but the amount of time the guys on my team spent coming up with questions for the interview, and not like you hear horror stories of like, oh, let's come up with a question that there's no way they'll be able to answer, but literally the opposite of that. Because you get people that are trying to prove how clever they are, and it's like, dude, you're the one hiring me. Like, you don't have to show that you're smarter than me. You're already in the position of power. Like, can we work together? We're already kind of off to a bad start. So their protocol with my team at Amazon was, you want to come up with questions that are ideally somewhat related to the day-to-day, that are not these weird algorithmic questions that no one, like, basically puzzles that the entire industry took, like inventing Tim sort, for instance. How do you do better than quick sort, like merge sort, but not merge sort, but stable, but, and hybrid sorting algorithms. Like, come on, the industry took 30 years to come up with that. So don't ask stuff like that. Ask something that is relevant. Have several levels. So have a really, really easy, and you ask the really quick question. It should take maybe 5-10 minutes tops, and that'll give the person some confidence. And if they can't answer the really easy one, you're like, all right, thank you. Next. But it should be trivial for them to answer the easy one. And then have a medium question that should take some thought to answer. And then have actually a hard one that probably not everyone will actually be able to answer. But you want to see, when they're really challenged, you want to see partly can they do it, but partly how do they respond? Do they shut down? Do they ask for a clarification? And when they would interview, they'd give everyone the cheat codes. They're like, hey, so when you're explaining this, talk us through what you're doing. We don't care if you're writing code on the board. We need to see your thought process. We want to understand how you're solving the problem. So even if you're stumped, talk us through things you think you could try. And they had one guy who had memorized, he had gone to one of these prep agencies, and he memorized some insanely complicated, this actually wasn't our team, but this was one of the worst interviews. And they asked him, how would you do this crazy, insane data structures, algorithms question? And he's like, oh, you would just do this. And they're like, really? That's all you do, huh? They're like, okay, well, what if you were memory constrained? How would you modify the algorithm to make it work still? And he's like, yeah, he had nothing. They're like, okay, so you don't actually know how to do that. You just memorize the question, and you actually don't know how to do your job. Thank you. But then on the other end, they had this woman that I remember one of my teammates running back in. He's like, dude, that was the best interview ever. He's like, that was incredible. And he asked her this question, and he's like, hey, so how would you solve this? And she's like, well, and right away, almost no hesitation, she's like, I guess I would try this. It's a terrible, really inefficient way to solve it. And she's like, but that's not really that efficient. She's like, yeah, that's going to waste a lot of memory. It's going to burn a lot of processor cycles. So she's like, really thinking about it, I guess I would change it into this algorithm. And that's better. She's like, but I think I could still optimize over here. And she's like, okay, so I think the final algorithm I would use this data structure combined with this algorithm, and we'd get pretty good performance. And that would probably be good enough for our specs, in production. And we could optimize it further, but we'd probably stop there. And like that is the ideal case where you immediately solve the problem, not optimal. And then you immediately identify optimizations. And then you immediately identify kind of final round optimizations, and then identify where to stop and not fixate on optimizations and make that a 20-year quest to find the most optimal whatever data structure. But like, no, like we'll get something going right now, because if something fell over and the server's on fire, it needs to work now. And then as we have time to think, now that we bought ourselves some time, how do we make it better? And then how do we make it good enough to be deployed for the next 5 years so we don't have to come back and deal with it again for a while? And so that, again, they would tell you this. They would give you this, like at the beginning of the call, they would just tell you, hey, tell us this, and they walk you through. And it's amazing how many people would just like go up to they wouldn't hear any of it. And they would just clam up, and they would just be like terrified, like, like, oh God, if I give the wrong answer on the test, I won't get the job. And it's like, well, we have no idea. You're not putting anything on the board. You're not explaining anything in your head to us. Like, you're just standing there. We got nothing to work with. So yeah, no, you seem like you're not going to be great to work with, because we need to collaborate on this. Give us something to help evaluate what's going through your head. And as long as the problem solving process is good, even if you totally botched this particular question, if your process is good, then you're going to be awesome to work with. And we don't really care. You're not going to figure everything out the first time, but we want to see the process is solid. So definitely pay attention when they give you gimmies, like take them. Listen to what they're saying. Like, a good interviewer is not trying. It's not a collaborative antagonistic thing. And if it is, like, next, go take another job. Just get out of there. But it should be like a collaborative thing. You guys should be both figuring out, as we've been harping on, do I want to work for this company? And then does this team, am I going to actually help them get more done after I onboard? Or am I just going to be dead weight, and they're constantly going to be having to, to kind of like, oh, here's what we're doing. Here's what I need you to do. And constantly like managing me. Because on a team, like, yeah, you'll have a lead, but for the most part, it's relatively equal on a team. You should have somewhere around 5 people. 8 is pushing it. I was on an 8-person team. More than 8, and you got a problem. That team needs to be split. And 8 is like the boundary where it should be 4 to 5. You can go as low as 2 or 3, but a team really should be somewhere in the neighborhood of 4 plus minus 2.
Yeah, I agree. Pizza-sized teams.
Yeah. Although they make those big novelty pizzas, so.
Well, yeah, but you can also have hungry people on the team.
Yeah.
But that's really great. All of that is really great for the whiteboard interview. But I forgot we didn't even talk about the take-home interview, which is a different kind of interview. It's actually the one that I did and scored my current position here. They didn't have me do any whiteboarding. And instead, what they had me do was they gave me a project, which was essentially a link to a GitHub repo. And I had to follow the instructions in the README and develop out an application that they thought, they said, make something cool with a third-party API and then submit it to this and let us know. And then we'll have an interview where we'll go over that code and we'll talk about your design decisions that you made in it. And this was my favorite interview of all. This is why I'm working where I'm working. I love where I'm working, by the way. Not even just saying that because they might be listening. I really actually love working at this place because the people were really great. Their interview process was very people oriented. It was like getting to know each other. We had a lot of time during the interview to just, talk about, different things that we're interested in. And for the most part, most of the technical stuff revolved around my submission of this project that I was given a week to work on. And so I was able, and they were like, you can put in as few as 6 hours into this thing, or you can use up the whole week if you'd like, but that's up to you. And we know that you're a busy person. So, you take your time and do what you want. Now I thought about it and I was like, well, you know what I could do is because it's an open-ended project where I get to work on something that I think is cool. I have this opportunity to work on something that I really think is cool, something that I would want to continue working on even if I don't get this job. And so what they're really doing is they're giving me an opportunity and a reason to start a new open source project, right? And so I made this cool project that I was really proud of, and I thought it was neat. It helped animals get adopted, and I was really into this project, and so I poured a lot of love into it, and it ended up being very high quality, in my opinion. And
Nice.
And when I got into that interview, we talked about, well, how could you make this more efficient? How could, what was your decision? Why did you choose to implement caching on this particular part? That wasn't actually part of the spec. And, I got to explain to them my thought process as to why I chose to do this. I felt like this was the optimal way to interview any engineer, really, because I've had the opportunity since then to interview other people using the same system at our company, and you can see how some folks just don't put very much into it. They put in the bare minimum, and in a project where they get to take it home and there's no pressure, you get to see the expressiveness of how much somebody wants that job, how much they how excited they are about code. And when they come in and they're talking about their code and they're excited to tell you all the cool stuff that they put into it for you, you can just get this feeling off the bat where you're like, I want to work with this person.
Look,
this person
I used the
looks
bloom filter.
yeah, right, exactly. So I really enjoy that particular type of interview, and I would suggest that if you are given this type of an interview, that you do use up all the time that they give you. I did get one where it was strictly timed. They were like, okay, you only have, I think it was 6 or 8 hours or something like that to do the whole thing. And you have to actually, we will send you the email, start a timer, and then we're going to end the timer at a certain time. And you're supposed to send us a zip or a Git, repo. That one was a little bit more tough, but I still managed to, it's interesting because it gives you an opportunity to show them where you're going to cut some corners in order to make everything fit within that time frame. But the ones where you have, it's open-ended and they're like, you can put as much time into this as you'd like, but we're going to have the interview next Tuesday. Oh man, it's such a cool opportunity to do something fun and cool. And so take that opportunity and really, put in the stuff that you think is cool. So this way, when you get to that interview, you're excited to show them the cool stuff that you want, because this will come through in the interview as part of your personality. They'll see how excited you are about that tech, how excited you are about the opportunity that they've given you. And you will very clearly differentiate yourself from the other candidates.
Yeah. Put in some bloom filters, some hyperlog log.
That's right.
But that's another thing too. Like, definitely, I like that, because if you've let them choose the problem, so you let them choose, like, it's the opposite of the whiteboard interview where they can do whatever they're most comfortable. Their own keyboard, their own workstation, like whatever their flow is, they're already in it. And then you've also, if they can't explain it, if you're like, well, why'd you do that? And they're like, and it's like, okay, but really, did you pay someone? Did you get someone on Upwork or one of those to write this for you? Because, like, seriously, this is your code. You should be able to explain everything you did. So what was the other thing? There's one other thing I wanted to cover. Oh, one thing I want to tie up a loose end on the questions, like the small, medium, and large questions. Another insightful thing for those hiring that's really important that gets overlooked a lot is, if you are hiring, then even if someone botches the interview, man, were you around for that one we had way back in the day? Irv was, anyway, it was this kid. They asked like a question basically about morals. Like, I think the question was, if you are on a project that is like months behind, like 3 to 6 months behind, basically there's no way this project is on time. It is very late. And I can't remember if it's like your boss asks you to lie to the client about it. What do you do? And so it's a really tough situation. And what do you do? Like, are you just going to lie to the client and like not have any accountability to the client? Are you going to disregard your boss? Like, it's a tough question. There's not like a clear cut answer, but it really reveals character. And this one kid just everything he answered, that question and the other stuff we asked him, we felt so bad. We just wanted to hug him and be like, so sorry, buddy. But like, it was the worst interview I've ever seen.
Do you recall the answer?
I think that one he was just like, oh yeah, I just lied to the client. And we're like, no, that's really awful.
Oh, I'm sorry. That's the wrong answer.
That's
actually
the worst answer you could have chosen. And then like everything else that we asked him and that anyone there asked him was just the worst possible answer. He wasn't knowledgeable. He didn't seem to have a strong moral compass. It was so bad. But even in a case like that, where it's like the worst possible, like complete down in flames interview, he might have a friend who's actually really good, who's actually who we want to hire. So even if you have someone, you shouldn't be like laughing at someone and be like, oh, what a moron. Like, why'd you even show up today? Right? Like, no matter how bad it goes, you should strive to have the interviewee have a good experience where even if they're just not even close to ready, like their skills, everything else, just like this guy, just no, there's no way we're hiring you. Literally the last person on earth that we're going to hire. I will take a 5-year-old and train them up before I hire you. But still, you don't want to be saying that to him. You want to be like, oh, well, we're really glad you came in. We're going to have to think about it. Just, don't be dishonest, but as much as you can, give someone a really good experience where they're like, I didn't get the job, but it was really fun. Like, I met some interesting people. I got some challenges that were, they were pretty hard. And, like maybe I'll try again in a few years, and leave a really good impression with the interviewees. Because again, if you make fun of them and you're like, wow, why did you bother showing up? Then they're going to tell their friends, they're like, dude, don't interview with that company. They're a bunch of a-holes. Like, stay away from them. And then it's going to be hard for you to hire anyone good. So always strive to have the interviewees come away with a really good opinion of the company, even on complete failure.
There's a saying, I heard it from The Undertaker in his Hot Ones interview while he was eating these spicy chicken wings. He said, the toes you step on the way up are attached to the asses you'll have to kiss on the way down.
Yeah, I remember that. It's a great line.
So you never know. A lot of people learn. I made a huge amount of mistakes, both, technically and probably even morally, in interviews in terms of my answers for a lot of these questions. And, I had to learn over time, what the right thing to do. I had to really honestly learn how to be honest during interviews. At first I thought it was tell them everything they want to hear. And now I've learned that it's best for everybody to just be completely honest in every way. And honesty is the best policy. It really, truly is. Because if you're being honest, you're able to genuinely represent who you are. And they're able to genuinely decide whether or not you're going to be a good fit. And this ends up good because, you don't want to get into that position where you tell somebody, oh, yeah, I know how to do that. And then they put you on the spot after they've hired you and you don't know how to do that. That's not what you really want. So you really want to be as true and authentic to yourself during these interviews. And if that kid really, truly was like, hey, you know what? I just lied to the customer. It begs the question of, what happens when you're not wanting to, what happens when you're in a tough spot with us? Are you just going to lie to us too? You feel comfortable with that? So you want to be honest in all things, and you want to be true to your own values. So this way you don't also find yourself being somebody who, you believe in a certain kind of value. You believe in things like, for example, a balance of family and work life, for example. And yet this company hears that and goes, he's not going to want to work here. We make him work, weekends and nights, That's a good thing. You don't want to work there if your goal is family and work
That was
balance.
Cliff's line, wasn't it? He's like, you can work whenever you want to, like all the time. And he wasn't kidding about that.
I think the most cliche version of it is whenever you get into an interview and they say, we like to work hard and play hard too.
Yep.
You watch out. That's a red flag right there.
Yeah. So, the one thing that you talked about was the interviews, and where you get to take home coding interviews. The other thing tying into that is have projects, have GitHub repos, have projects. Like it's a good sign when someone comes in, especially if you bring in your own laptop. Like laptops, and everyone has a laptop these days. I remember when those were like a luxury, and now like almost no one has desktops anymore, hardly, except for gamers. So if you see someone that has some really cool customizations, that's a good thing. If they have some projects and you can tell like this is what they love doing, that's a good thing. Build a portfolio. I had one kid that I met just purely by chance. I was doing school advisory work and I just happened to meet this woman, and she's like, oh yeah, my little brother's, he wants to get into tech. He doesn't like school and he wants to get into tech. I'm like, okay, well, there's a lot of us who are self-taught, and yeah, we didn't go to school. It's not, I mean, in some ways, if you like just constantly doing research and learning, it works well. But if you're not someone who's going to just go and constantly read, like you're not getting into tech if you just like don't go to school and then just show up and be like, hire me, I'm smart. That's not how it works. Like one way or another, you're going to have to put in the time. And if you're not someone who's going to put in a huge amount of time to better yourself constantly, you better go the school route and just do what they say. And they're going to tell you what you need to know at a minimum. And it is easier. Like self-taught is not necessarily easier. It definitely takes longer. I prefer it, but it's not for everyone. So this kid, he's like, I don't want to go to school and make a whole bunch of money in programming. I'm like, all right, well, show me what you got. Like, let's see, show me your projects. And he showed me like a poker game. I'm like, okay. Like, what else you got? And he's like, well, he had like one or two like tiny little nothing repos. And I'm like, dude, like, this is not going to get you a job. Like, you can't just not go to school. Like, what have you been doing? Like, I would not hire you right now. Like, you're going to have to show why without the schooling. Like, I've met some kids that you're like, let me see what you got. And they're like, oh, and I made this and I made a neural net. And you're like, geez, like we had one kid at Code Day who from scratch did a neural net. Not too many neurons. It wasn't very deep, but he showed that he fundamentally understood how a neural net operates. Like built one from nothing, from just straight up Java with no framework. And I'm like, that's insane. And he's like, can you help me? And I'm like, I'm like, I understand the principles of backpropagation and I follow some of the research, but I have not ever coded a neural net from scratch. I will try to help you. So yeah, right.
That reminds me of that Big Bang Theory scene where their car breaks down and it's full of nerds, and he goes, who understands how a combustion engine works? And they all raise their hand. It's like, who knows how to work on a combustion engine? And they all lower their hand. So
exactly. So, and then the other thing that I want to make sure we get in, since we've gone ahead and made this a 2-hour episode, which I think is good, though. We covered a lot of good stuff. I put together just earlier today, I've been trying to get a lot of the stuff that we're doing on the podcast and elsewhere because of all the consulting I'm doing. I want to be able to like hand off stuff. We started doing some articles on egx.org. We have 2 up from our initial series. It's a 3-parter that'll be happening in January. But I've been trying to do some guidance for people to just kind of like, hey, go look at this. And if you want to talk about the next step, like where do we go from here? Then we can talk. Then you'll understand the basics. And one thing that really bothers me in computer science education and hiring is we talked about tech earlier, but there's just some basic stuff. You don't need to know all this. I don't even care, honestly, if you know a little bit more than the name. Know the name and give me a sentence or 2 on each one of these things. And that's super impressive. There was one kid I met at Code Day when he was 14, and man, we're waiting for the parents. We're all like tired as heck. It's been 24 hours. We're all just done. And his parents haven't showed up yet. And I'm like, well, like, tell me what you've been working on, man. What's the coolest thing you learned? And he's like, oh, dude, dependent typing is really cool. Like in Idris. And I'm like I just learned about that. I've been doing this for 20 years and I just learned about what dependent typing is and why it's amazing. from someone I deeply respect. And this 14-year-old's like, yeah, dependent typing is like really cool. And I'm like, that's absolutely amazing. Clearly, this is a kid who not just is interested and not just put some stuff together, but spends some serious time researching computer science. So stuff like just language categories, like when I'm doing educational advisory work, one of the things that really bothers me is I used to say stupid stuff like this. So I'm not going to cast a stone very hard because, like I said, we've all kind of been here, and you learn a few languages and you learn JavaScript and a little bit of Java and maybe some Python and, Perl and Ruby and just most of the languages that are out there, Go too. What you don't realize is all of those languages, everyone's like, oh, once you learn one of these, it's really easy to learn another. Okay. But that's just because you're in one category of language. Those are all imperative procedural or imperative OO languages. And within a category of language, moving from one to the other is basically just memorizing new syntax. But that's a lot different than switching from, let's say, an imperative to a declarative language, or going from, a functional language to a concatenative functional language, or a logical to a probabilistic language. Like, there are vastly different types of languages, and moving between language families is extremely difficult, or can be anyway. Like a probabilistic model, those are pretty rare, and those are really good. If you're modeling a pandemic or you're modeling traffic flow, you don't want to be working with discrete numbers. You want to be like moving probabilities around and working with confidence intervals and calculating how, probably the traffic, what's my upper bound, lower bound, how is this going to vary with these conditions? There are entire languages designed to work with uncertain numbers and probabilities to their core. I mean, you could try to write that in Python. You could try to cobble everything together in C or Python or Java, or you could just use the language that's already there. And this is what really bothers me with a lot of the computer science and STEM education, is they focus on the popular languages, which are all imperative, like I said, imperative OO, imperative procedural, which are fine-ish. They have some weaknesses. And it's basically like if you were teaching someone carpentry and you're like, so here's a hammer. And they're like, well, what else is in the box? You're like, yeah, hammer. We could have a red hammer. You could have a blue hammer. You could have a green hammer. And it's like, oh, but what if I don't need to hammer a nail? What if there's a screw? I mean, I guess I could bang on the screw and eventually pound it into the wood, but isn't there a better way to drive a screw than pounding on it with a hammer? And you just don't get exposure. And it's like, yeah, there's, if this isn't working, if you're using an imperative language, but what you really need is to do an exploration of a logical space, like, I don't know, from our past, if you needed to lay out a circuit, if you had a finite amount of silicon and you had some chunks of semiconductor, like some different groups of different components of a circuit, an integrated circuit, how many ways could you, get them to lay out? And could you do so in such a way that the circuit actually worked and didn't interfere with itself? So you could use something really cool like Prolog. You could use a logical language and teach it all the rules of these have to be this far apart. These can't be any farther than this. Nice. So know what's in the toolbox, like understand. And like I said, you don't have to be able to explain to me what a concatenative functional language is. That's cutting edge stuff. But if you're just like, oh yeah, and I heard about this thing, it's supposed to be really cool, cutting edge concatenative, but I know that most stuff is still done in procedural and declarative and functional. If you at least know and can name the tools in the toolbox, and that, oh, wow, I heard about a language that would do really well for this problem, then that's a big thing. Like, that's going to save a ton of time. I don't know as much in a larger company, but definitely in a startup. Like, for the life of me, I don't know why Amazon's whole infrastructure is in all Elixir and Erlang, but whatever. They spend a lot of time trying to reinvent Elixir and Erlang there.
Well, I've heard a lot of companies. I've worked for a lot of companies that try to hire for one technology and they just figure that they can train them on another technology, and they think that they can get, a double bang for their buck, for that. And it rarely works. If you have a Ruby developer, they are most likely not going to be that great at JavaScript, and vice versa. There are folks who know both and they do pretty well. I like to think of myself as one of them, but the truth is that it takes, there are very few opportunities where you get to work with both of those on a daily basis in order to get good at them. And there are differences between those languages, maybe not in terms of the capabilities of the language. Maybe they can just read the documentation and absorb it and understand it. It's in terms of the best practices that come over time, where you have to learn what has been tried before, what have people actually done in this particular language, thinking it was a good idea, but we had to learn through some experience that in fact it doesn't have the return that we thought it was going to have. So yeah, absolutely. It's certainly a bigger problem when you get, when you're changing paradigms entirely. Like, for example, I've had a lot of Ruby engineers say that they're interested in things like serverless architecture, but when you, but the whole idea of like how that works seems like voodoo for them at first. And you have to show them examples of why certain things that seem like it would work very easily just end up not working because of certain limitations, things like that. Hugh, in our chat, had said that for him, honesty didn't work. He said he's brutally honest about what he knows and what he doesn't know. And the interviewers seem to be not impressed about the things that he doesn't know. I think that that's a good thing, Hugh. I honestly do. I think that there's a silver lining attached to that. When I was going into these interviews and I told people that I didn't know React enough times, that I lost the job enough times because it's just that popular of a technology, I ended up having to turn around and take a look at myself and say, you know what? I need to learn React. I really do. I need to get a project going, and I need to start like actually understanding this to the point where when they ask me, do you know React? I can say confidently, yes, I do. And when they have some certain questions about, about different, it's been a while since I've done anything with React. So yeah, I know I need to refresh it. But
my answer is no, I don't know React, but I know Elm, which is where they cribbed all the ideas from.
Well, the point is that you want to be able to answer certain kinds of specific questions. You want to make sure that you know what others are talking about when they're speaking about React or whatever the technology is. If it turns out that, they weren't impressed by you not knowing Git, well, it's your opportunity to learn Git.
That's different.
It's just an example. It's just an example.
Yeah, but Git is foundational tooling. React is just some trendy crap that's way overused.
Well, a better example would be Postgres. Okay.
Yeah.
If you say, I don't know Postgres, and they go, well, we really need people who know Postgres because there's very specific features of Postgres that are not available in MySQL, that aren't available
Postgres
in other kinds. Has
always been way out ahead in features. Always.
Yeah, and they may heavily use those on a daily basis, or depend upon what they're hiring for is somebody who really knows Postgres and can bring them to the next level. Well, then, it's actually a good thing that you didn't get that job, because they would have brought you in. They would have expected you to give presentations on how to level up everybody at that company in Postgres, and you wouldn't have known how to do it. And that would have not looked good for you, and it would have wasted some time.
It depends on, are you coming into a, junior, mid-level, or senior role? And if you want to learn that technology, like honestly, React is fine. I get really annoyed with React because React is overused. I'm sick of seeing blogs that are showing me like 5 paragraphs of text that are React. And it's like, what are you doing? I actually had a business that we were aligned with, and they were like, oh, we're going to build it in React. And I'm like, you're building a blog. Why are you pulling in React? Like, it's so overkill. You don't have things that you're not building an app. You're building a blog to show text. HTML and CSS are amazing at that. Just stay there. If you need to build it into an app, fine, React, but don't start there.
You and I argue about this all the time because My argument back to you is always, you don't know the full scope of what it is that they're trying to do. Maybe they do have future ideas of making this thing be
We
an
talked
app.
about it.
Maybe they
Yeah.
have future ideas of this thing being a learning project for them to be able to understand React.
We talked about it, and I diverted him. I'm like, just do something simple like Rails or choose your other favorite, framework like that. And they're like, oh yeah, this is saving a lot of time. In that case,
So I'm not getting the
choice.
job because the feedback to me was that I don't know React, and your suggestion is, build it in Rails. I mean,
No,
that's what I'm saying.
My suggestion is, if you want to learn React, then by all means do. But I also I see a lot of companies that use, especially now, it's very trendy. There's all these technologies they throw out there, and we're not even getting into the crazy stuff like AI and blockchain. Like I talked this one dude at an adult hackathon off a ledge, and I'm like, oh, what's your project? I was mentoring. I'm like, yeah, what do you guys got going on in here? And he's like, oh, we're doing this AI, IoT, blockchain project. I'm like, oh God. I'm like, if you're in Silicon Valley, like $5 million in balloons and confetti would have just fallen from the ceiling because you got bingo, dude. And he's like, what? I'm like, never mind. So I'm like, what are you doing though? What's your project? And he's like, so when they ship medicines like over the ocean to like Africa and stuff, and they have to stay cold. I'm like, yeah. He's like, all right, so we're going to have these little sensors in there. And he's like, the problem is they have sensors. And then when the medicine shows up, if it got too warm, they open the crate, the container, and it's like, yeah, the medicine's no good. And then they got to, it takes months to go across the ocean. So now they got to send another shipment. And now instead of the medicine getting there when it was supposed to, you're talking like months and months later. And I'm like, oh, that's a good idea. So I'm like, where's the AI coming in? And he's like, oh, to tell if the temperature is, if it got too cold. And I'm like, that's a conditional. If temperature is, greater than whatever the cutoff is, where's the AI? It's really one conditional that you need. There's no AI. He's like, oh, well, yeah, he seemed like really disappointed he couldn't throw AI at it. I'm like, it's literally one fucking conditional. And then I'm like, all right, so where's the blockchain thing? He's like, oh, well, he's like, we're going to have blockchain, we're going to have an API. I'm like, stop. What did you just say? He's like, API. I'm like, no blockchain. He's like, huh? Like the whole point of a blockchain is that there's no single point that you connect to. You want a diffused distributed system. So API and blockchain, no, those do not go together. If you're doing an API, you're not doing a blockchain. Otherwise, you're just wasting computer cycles for no friggin' reason. It's one or the other, dude. And he's like, okay, well, we'll just do the blockchain. I'm like, well, wait a minute. Have you trust mapped your system? Where are all the points that people have to trust? I'm like, are you selling these little thermometer things? Is it just your company or is this a standard? And he's like, well, it's just us. Okay. So people have to trust you to make the hardware properly. And you could just have an API and they already trust you for the hardware. And if they trust you for the API, like if you basically own the whole system, why would you bring in the inefficiencies of a blockchain? Because everything, like you are the single point of trust. If you're not doing this as an open standard where you have multiple parties that are all maybe not quite trusting each other, maybe blockchain's not a terrible idea. So anyway, I talked him all the way down and yeah, it was IoT. I'm like, assuming you can get a signal out of a shipping crate because, metal Faraday cage, good luck with that. But I'm like, it's not a bad idea, but our whole industry, sorry to go off on a rant there, but it drives me nuts when you see people pitching these insane AI, robotic, IoT, blockchain. You're like, stop. You don't need any of that. You also don't know. There was a thing I posted on LinkedIn the other day where they were talking about like learn the fundamentals of AI or data science. And I was like, what you need to learn is when it doesn't work. And I had a whole bunch of people in the field that are like, yeah, yes. Because what people don't know is they think it's magic. They think you just AI the thing and it just magically is incredible. And it's like, no, like there are failure modes you bring in. And if you need to do a certain thing, then it's awesome to bring in machine learning, but only if you cannot get that same thing accomplished with a much simpler construct. And so anyway, there's so many problems that we're seeing right now. And I won't blame SolarWinds on this. Although a little bit, trendiness and security is definitely partly to brand. Like SolarWinds comes from that. When people are just throwing trendy crap at the wall and they have no reason to actually do it. It markets well. It sounds cool. They want to be cool and hip. And it's like, no, again, understand your toolbox and apply the technology that solves the problem in the quickest, simplest, most resilient way possible. Don't throw complicated shit at the thing just to sound cool. That's the root of all bugs and security issues and all evil, basically.
So a lot to unpack there. I generally agree with you, though I would have to push back and say, if we don't say it includes blockchain and machine learning, how are we going to find an investor? I mean,
indeed.
We have to have some buzzwords in there. Come on. At least those are easy ones.
Let's do the incantation. Blockchain, AI, IoT, robotics, quantum. Yay, money, right?
I do want to answer another question from Hugh, or one of his, maybe unsolicitedly answer a statement that he had made. He said when he was applying for a junior job, and he found it weird that they say they need somebody with 2 years experience for a junior job, and they expect a junior to come with hands-on experience and knowledge. The way that you get around that is an open source project. You go onto GitHub, you make a project, and you build something cool, and you end up coming to that door and you go, look, for the past 2 years, I've been working on this cool thing. And you get to explain it, and you get to go in there just the same as like one of us going in there with one of our projects for, for these interviews. And you get to go in there excited about it, excited to show off, all these things, and it's a testament to you having experience and hands-on knowledge with, with whatever it is that you're trying to get the job with. So that's a good way of getting around that problem. It's also the reason why a lot of people in college, like art majors and folks like that, graphic designers, they come out of college with a portfolio, because that shows that they actually have some hands-on experience with doing the things that they're doing. Let's wrap this up with just a recap again of what people are doing, what you want to be looking for. I think we already talked a lot about interviewing the company, and I think people can go back in the episode if you missed that. You can listen to it. It's about the halfway mark of this episode. But in the end, I think the other side of this is also things like soft skills. And we didn't really talk a lot about those. And I want to touch on a couple of things with that. One is be very positive during your interview. And all I mean by that is if you're somebody who just came from a company that for example, I had just been working at a company and I didn't have a great experience at that company. And I was interviewing at these other companies, and they asked me about my previous position. And I lost a lot of those positions because I wasn't talking as positively as I could have been about that previous position. And I think that folks were reading into that. They see it as a red flag. They go, well, how are they going to be talking about us at the next interview? Yeah. And so don't talk ill of the companies you've worked for, no matter how bad the experience might have been. Find the things that were positive about that experience. And this is just generally good. This is a generally good advice for your life. Find the positive find the silver lining in that cloud, and make sure that's the emphasis you put on things. And go ahead.
I will say, especially in Arizona, I can't speak for other major cities. I don't think as much in Seattle, and I'm not sure about New York and other areas, but Arizona especially, do not burn bridges. We are a very large city. We're about the 5th largest metro in the country. But we are also a very small town. Like, they're in your industry, whatever portion of tech you're in, and other industries too. If you get a reputation, if you don't treat people well and you don't act honorably, it doesn't take long, and no one wants to do anything with you. So you're going to have to go move to San Francisco or Seattle or wherever, because it's crazy with how much land we have and how big a city we actually are. Do not burn bridges here. Terrible idea.
And you don't have to be a Glee character. You don't have to go in there and be overly and artificially positive, optimistic, person. Just go in there as your happy self and speak genuinely well of the people that you used to work with.
It's like your teacher used to tell you, if you don't have anything nice to say, just don't say anything at all. There's some stuff, just don't misrepresent, just don't bring it up. And if they ask you, just be like, well, we had a difference of opinion, Yeah,
and, even better, find something you did like about those people, something you did like about that position, and emphasize that during the interview. That's very important because more and more today, it wasn't as big of a thing when I was starting off in my career, but cultural fit is a very big thing these days. Yeah. People have recognized that happy is productive, and they've recognized that unhappy people are toxic and they will actually take down other people's morale. Morale in a company, especially if you're doing something tough, especially if you're trying to do, you're trying to recover from something like COVID, especially something like that. And what I mean is the effect of COVID on the economy. You're trying to go in there and show people that you're not going to be a threat to the morale that might already be low at that company. You're going to be somebody who's going to come in, inject some new energy into the company and be like, hey folks, I'm here. I'm ready to do work, and I'm ready to, send memes on Slack and have fun with all of you, and that's really what, people are looking for. Is they're looking for somebody that's going to be able to not just do the job. There might be 3 or 4 candidates that can do the job. The one that they choose, the one they want to work with the most. All right. So
hopefully they're not using Slack.
Well, we'll get into that. We can talk all about business tools maybe on the next one, because that's a whole other thing, and it is pretty fun to hash that out. I've used quite a bit, and I've learned of some that I haven't tried yet, and I wanted to talk to you about those at another time.
Got any notions?
Well, I some cool tools that have to do with project management that. Yeah, we'll bring it up at another time because we're at the end of our episode, folks. We're at the 2-hour mark here. And before we go, I do want to thank everybody for sitting here and listening to us talk about hiring. If you have any questions about hiring, please do send an email to shows@fault-tolerant.com. And fault-tolerant.live. So shows at fault-tolerant.live, and we will make sure we answer those on the next episode. And we'll be recording another Code and Chaos here on Monday. So tune in then. We'll have that up on the Fault Tolerant Twitch schedules page, show schedules page. We did do today's recording was a little bit late. That was due to some car repairs and things that we had to get done beforehand that we just couldn't push off. So we pushed it off, and everything looks like it's all right. So folks, thank you very much for showing up and listening to us for the past 2 hours. Elio, anything you want to say to everybody?
No, glad we got a chance to go over this. And like I said, we'll have a few more discussions, and at least locally, trying to make it easier for good people to find good work, because we need all the help we can get.
I completely agree. And we also have, on the next episode, we'll talk a little bit about some of the ideas that Elio and I have for being able to help everybody out in a bigger way, interactively, and have some fun with that. So, everybody, thank you very much for tuning in to Code and Chaos on Saturday. We will see you on Monday. Take care.